So the first topic for today is the properties of convolution. So the first property of the convolution is the commutative property. A commutative property is just if we convolve H1 and H2, it is the same as we convolve H2 and H1. Okay, if we change the order, it doesn't make any difference. So to see if this commutative property is true or not, we will take an example. So once again, the commutative property is if we convolve H1 into H of 2, and if we convolve H2 into H of t, so it will not make any difference. So ये चीजें हमने देखी भी थी कि अगर हम h of t minus tau को कन्वोल्यूशन में स्लाइड करें या x of t minus tau को स्लाइड करें तो इसमें कोई डिफरेंस नहीं था. ओके, सो हम कैसे प्रोसीड करेंगे? जितनी भी हमारे पास प्रॉपर्टीज हैं उनकी हम लेफ्ट साइड और राइट साइड दोनों को अलग अलग कन्वॉल्व करके, दोनों को अलग अलग फाइंड करके फिर उन दोनों के रिजल्ट्स उनको हम कंपेयर किया करेंगे. ओके, लेट्स कंप्यूट द लेफ्ट साइड ऑफ दिस commutative property. As an example, we have taken h1 of t, which is 1. So h1 is 1s and the time is from 0 to 5, and h2 is 2 e raised to power minus 2t. So first of all, we have defined the time, the signals, and then we have convolved. So if you remember, last time we studied that with the convolution command, you multiply with the time step, which is 0.05. So if we plot this, we can plot. There is another trick we used last time. Convolution जो होता है वो double time interval के लिए होता है. If you remember, वो double time interval के लिए होता है. तो what do we do here? हमने क्या किया? 0 से start किया और इसको हमने जो हमारा original time period था वो 5 था. तो अब हमने ये क्या किया? हमने double time interval के लिए इसको plot कर लिया. Okay. So similarly, to compute the right hand side, हमने क्या किया? Simply कन्वॉल्व किया है h2, h1. यहाँ पे हमने h1 और h2 को कन्वॉल्व किया था, एंड बाकी चीजें सारी सेम है. सो लेट्स सी हाउ are the two sides. This is the figure 1, this is the figure 2. In the figure 1, h1 is convolved with h2, and in the figure 2, h2 is convolved with h1. So you can see that both the figures are same. Similarly, the next property is the associative property. Associative property is if we convolve h1 and x1 first and then h2, it is the same as if we convolve h2 and h1 first and then x, and that then we convolve the h2 and h1's answer with the input. So again, we will take the time 0 to 5. X is 1 from 0 to 5. It was u of t minus 5. That means it's a pulse between 0 and 5. So we can define it like this, because time हमने define कर दिया from 0 to 5. So बाकी सारी जगहों पे ये 0 होगा, सिर्फ और सिर्फ ये जो time है इस पे 1 होगा. So we can define x like this. जो h1 है that is 1 by pi t, हमने define कर दिया है. And similarly h2 is 2 e raised to power minus 2t, हमने define कर दिया है. The time is same for each of the signals. हमने last time देखा था कि कन्वोल्यूशन के लिए टाइम से जो जितने भी सिग्नल्स हैं जिनको हम कन्वॉल्व कर रहे हैं, दे शुड हैव सेम टाइम इंटरवल. सो यहाँ पे टाइम इंटरवल सेम है फ्रॉम 0 to 5. नाउ अब आप क्या करेंगे? अगर लेफ्ट साइड कर रहे हैं तो यू विल फर्स्ट कन्वॉल्व h1 एंड x. वो हमने यहाँ पे किया है. द आंसर इज y1. सो वी नो कि जो ये y1 है इसकी लेंथ क्या होगी? कैन एनीवन टेल मी y1 की लेंथ इस केस में क्या होगी?
सर डबल होगी जितनी हमारे पास जो
डबल हो जाएगी. बिल्कुल, तो डबल हो जाएगी. इसका मतलब है कि अगर इसके साथ हमने एक और सिग्नल को कन्वॉल्व करना है तो हमें क्या करना पड़ेगा? उसके उस सिग्नल का टाइम, उसकी सिग्नल का जो टाइम है वो भी इतना ही करना पड़ेगा, यानी फ्रॉम 0 to 10 करना पड़ेगा. अब ये जो y1 है दैट इज फ्रॉम 0 to 10. सो अब हम इसके साथ हमने h2 को कन्वॉल्व करना है. सो h2 का जो टाइम होना चाहिए वो भी इतना ही होना चाहिए. लेकिन अगर आपको याद हो, लास्ट टाइम हमने एक रूल किया था कि जो अगर पीस वाइज सिग्नल्स हम लेते हैं तो उनका जो टाइम है वो आपस में ओवरलैप नहीं होना चाहिए. So there should be no overlap between time periods of different parts of a signal, a piecewise signal. So अब हमने क्या किया है कि जो एक्स्ट्रा टाइम होता है, यानी हमने कैटिनेट करना होता है एक्स्ट्रा टाइम, और उस पे सिग्नल को हम 0 कर देते हैं. सो वो जो एक्स्ट्रा टाइम है दैट शुड बी स्टार्टिंग फ्रॉम द नेक्स्ट टाइम इंटरवल, यानी 5.01 से स्टार्ट हो रहा है, वो अगर 5 पे खत्म हो रहा था पिछला टाइम, दिस शुड बी स्टार्टिंग एट 5.01। ठीक है, ये टाइम्स ओवरलैप नहीं करने चाहिए। अब हमने क्या करना है, अब हमने ये करना है कि H2 तो डिफाइन था प्रीवियस टाइम के लिए, अब हम क्या करेंगे, H2 एक नया सिग्नल डिफाइन करेंगे, दैट विल बी जस्ट 0 ओवर द नेक्स्ट टाइम पीरियड, और फिर इन दोनों को कनकैटिनेट करके H2 बना लेंगे। हमने ये किया कि H2 और ये जो इनका रिजल्ट था, इनका रिजल्ट जिसको हमने Y1 कहा हुआ है, इनका टाइम सेम हो जाए। ओके, बिकॉज यहाँ जब हम H1 और X की कन्वोल्यूशन करेंगे तो देयर टाइम विल बी डबल्ड, फ्रॉम 0 to 10 हो जाएगा। So okay, now we will convolve the H2 with the Y1 again with the multiplied with the time step, and after that we will plot this. By the way, this line width is to increase the line width. We will compute the right side. The principle is same. In दोनों को हम compare कर लेते हैं. So if we compare the both sides, we can see the left side and the right side, the side of the equations are same. It means the associative property is proved. Okay, so the next property is the distributive property. Distributive property होती है कि if you add H1 and H2 and then multiply them with the input, what you can do is you can multiply H1, or you can take convolution of H1 with X1 and then add the other convolution with it. So H1 into X1, and you can add them with the next convolution. So for the left side, what we have to do is we have to first add H1 and H2 and then convolve with X. So we will define H1 and H2. H1 is cos pi t, H2 is 2 e raised to power minus 2t, time is again 0 to 5, and U is the same. Now X is the same. Okay, so we will define each and every signal. X is ones from t, which is 0 to 5. H1 is cos pi t, H2 is 2 e raised to power minus 2t. So first of all, we will add H1 and H2, and then we will convolve this H with X. Okay, and all of the other principles are same. Now on the right side, what we will do, we will convolve H with first H1 with first X, and then H2 with X, and then add the results. So we have done the same thing. We will define H2 and H1, H2 and X, and then we will convolve H1 with X first, and then H2 with X, and after that we will add the results and then plot this. So let's see what are the results. So we can see that the results are same. So first adding the impulse responses and then multiplying with the input is the same as multiplying the input with the impulse with the system or impulse response, or we can say the convolving the system with the input and then convolving the other system with the input, and after that adding the result gives you the same results. So this is the distributive property of the systems, and that's it from the property side. इसके बाद कुछ और चीजें हैं जिनको हम डिस्कस कर लेते हैं, which is the interconnection of systems. By the way, जो properties हमने देखी हैं इनको आप relate कर सकते हैं interconnection of the systems के साथ. So let's suppose we have a system S1 and another system S2, and the system S1 has the impulse response as H1, and the system S2 has the impulse response H2. So if we have the impulse responses, we don't care what the system is, we don't care what are the equations, what are the transfer functions, etc. We don't want to know about them. We have the impulse response. So अब क्या होगा, if we provide an input and convolve with the with the impulse response of this, and then simply whatever the answer is, convolve the answer with the H2, we will get the output. This type of configuration is called the cascade configuration. Yes, को हम series भी बोलते हैं. The second configuration is the parallel configuration. In this, the systems are connected in parallel. So what we do is we convolve X with the H1 first, and then we convolve X with the H2 first, and then afterwards add the results, and then we will get the output. And the C is the mixed configuration. In there you can see that we have added first two systems in the parallel configuration, and then we have added another system in the series configuration of these both, or cascaded configuration of these both. So what we will do, we will convolve X with the H1 first, then X with the H2 first, and the result is then convolved with the H3, and we will get the answer. The last configuration is the feedback. In the feedback, what you do is you give the input to a system S1, and whatever the output is fed back to the S1 by first multiplying with another system. Whatever the answer is, that is fed back to the system S1, and the output of S2 is combined with the input and then given to S1. So this is a loop, and this is called a feedback configuration. अब इसको solve कैसे करना है हमने? So first we will take input and we will take the input and we will convolve with the H1, and whatever the answer is we will give to the system S2, and we will convolve the answer with S2, and then whatever the answer of this is we will combine with the input and then we will give to the H1. So let's move to the coding part. So this is the cascaded interconnection. अगर आप इसको relate करें इन्हीं figures के साथ, this is the same as जो मैंने अभी आपको बताया. Okay, what you do is you convolve x firstly with the H1, and whatever the answer is you convolve that with the H2. Now there is another alternative of this, that is if you apply the associative property we just discussed above. So you can write this equation as this. So what you can do is you can take H1 and H2 together, and whatever the results, whatever is their result, you can convolve it with the x of t. Okay. So it means that we can combine these impulse responses together and we can write them as h of t. So what does that mean? So this means that in the cascaded connections, if you have multiple systems, what you can do is you can combine, you can multiply their impulse responses, and you will get a you will get an equivalent impulse response. इसका क्या मतलब है? इसका मतलब है कि if you have multiple subsystems in series, you can multiply their impulse responses, you can get one greater system, and this will be the equivalent of all of these systems. और उसका जो impulse response होगा, we can call that impulse response as H. Now you can what you can do is just convolve the input with the equivalent system's impulse response, and we will get the output. Okay, so now let's take the left part and compute the left side first, and then we will take the right side, means the equivalent system, and we will compute that in the next portion, and then we'll compare these two. So if we compute the left side, we have defined the system, the systems for the time t is from 0 to 3. Signals are, again, x is a pulse, h1 is t raised to power minus 3t, और इसी तरह h2 क्या है? h2 is t cos 2 pi t. So we will define x, we will define h1, we will convolve them, and after that we will define h2, and आपको पता है कि h2 के लिए what we have to do is h2 को हमें इसका जो टाइम पीरियड है वो फ्रॉम 0 to 3 था, इसको हमें डबल करना होगा, बिकॉज नाउ वी हैव टू कन्वॉल्व इट विद द आंसर ऑफ दिस कन्वोल्यूशन. सो वी हैव डन दिस हियर, और इसके बाद हमने क्या किया है कि कन्वॉल्व कर दिया इन दोनों को. सो नाउ वी विल गेट द लेफ्ट साइड. सिमिलरली व्हाट वी कैन डू इज कंप्यूट द राइट साइड. राइट साइड के लिए हमें क्या करना पड़ेगा? हमें पहले इक्विवेलेंट कन्वोल्यूशन फाइंड करना पड़ेगा h1 और h2 का. सो यहाँ पे हमने यही किया है, h1 फाइंड किया है, h2 फाइंड किया है, इनका इक्विवेलेंट जो कन्वोल्यूशन है वो हमने यहाँ पे कंप्यूट किया है, और उसके बाद हमने क्या किया है, और उसके बाद जो इक्विवेलेंट कन्वोल्यूशन होगा x, उसको हम क्या करेंगे, उसको हम सिंपली कन्वॉल्व कर देंगे x के साथ. ठीक है, यहाँ पे हमने ये किया है, और इसका हम रिजल्ट देखते हैं. सो लेट्स सी द रिजल्ट. सो यू कैन सी दैट दिस इज द लेफ्ट साइड एंड दिस इज द राइट साइड. So you can see this is the y of t computed with the left side, and this is the y of t computed with the right side, where we have used the equivalent impulse response. So इसमें जो important चीज है वो ये conclusion है कि in the series cascade configuration जो equivalent impulse response है that can be found by multiplying each and every impulse responses. ये दो की हम बात कर रहे हैं. अगर सैकड़ों के हिसाब से सिस्टम्स भी हैं तो आप क्या कर सकते हैं, उन सारे सब सिस्टम्स के इंपल्स रिस्पॉन्सेज को आपस में मल्टीप्लाई कर लें, और उसके बाद आप उसको एज ए वन सिस्टम ट्रीट करेंगे. ओके, दिस इज द कैस्केड कॉन्फ़िगरेशन. नाउ लेट्स मूव टू द पैरेलल कॉन्फ़िगरेशन. सो जनरली क्या होगा कि x1 विल बी मल्टीप्लाइड कन्वॉल्व विद h1, and x of t will be convolved with h2 separately with the two systems, and then after that we will add the results. So अगर हम distributive property apply करें तो we can say that x of t can be convolved with the combination of these two. Now we can say the addition of these two is the equivalent impulse response. So what does that mean? That means that if we have some systems in parallel, what we can do, we can just add their impulse responses and find the equivalent impulse response. Okay, let's prove if this is true or not. So for that we will first find the left hand side of the equation, and then we will find the right hand side of the equation, where h of t will be simply the addition of the impulse responses of the systems. तो हमने यही किया है, h1 ये है, h2 वही सेम है, t x भी सेम है, सिंपली हमने क्या किया, लेफ्ट साइड को हमने कैलकुलेट किया है और सिमिलरली राइट साइड को हमने यहाँ पे कैलकुलेट किया, जहाँ पे h हमने कैसे फाइंड किया है, h फाइंड किया है h1 और h2 को ऐड करने से. So after we have found the h by adding h1 and h2, अब हम जो result है उसको हम convolve करेंगे with the x, and now we will compare the results. So let's see. So we can see that this is the left side, where we have multiplied x1 with the individual system and then added the results, and this is the right side, where we found the equivalent system first by just adding the impulse responses, and then we have convolved the equivalent system with the x. We can see that both the results are same. तो इसका मतलब क्या हुआ, इसका मतलब ये हुआ, okay, we can say that h of t is what? H of t is the combination of all h of t is the combination of all the impulse responses which of the systems which are connected in the parallel manner. Okay, and in the similar fashion you can prove the other as well. So after that, for the stability criteria of the systems, you have basically one definition we already studied, which is the BIBO stability. So can anybody tell me what was the BIBO stability criteria?
अच्छा, उसका ये था कि जो आप बाउंडेड इनपुट थी वो बाउंडेड आउटपुट भी हो. फॉर एग्जांपल अगर आपकी इनपुट एक फाइनाइट आप उस इंटरवल में डिफाइन कर रहे हैं तो उसकी आउटपुट भी फाइनाइट आनी चाहिए.
एग्जैक्टली कि आप एक फाइनाइट इनपुट प्रोवाइड कर रहे हैं तो आउटपुट शुड बी फाइनाइट. ठीक है, इट्स नॉट नेसेसरी कि उनके टाइम इंटरवल सेम होंगे इनपुट और आउटपुट के, लेकिन आउटपुट शुड नॉट बी डाइवर्जिंग. सो दिस वाज द फर्स्ट मेथड. ओके, नाउ if we know the impulse response of a system, then there is another criteria to find the stability, which is we can say that an LTI system is stable only if its impulse response is absolutely integrable over minus infinity to infinity. Okay, and the expression for this is just the absolute of h of t, and we will integrate it from minus infinity to infinity. So we can do the same thing in the MATLAB as defining the time in the symbolic platform, and defining whatever the impulse response of the system is, and taking the integral of absolute of h from minus infinity to infinity over time. Okay, so if we check the first part, we have taken some h or impulse response as an example. So let's check what is the result. So we have the result. Yes, this is the answer. What does that mean? That means that the integration over minus infinity to infinity of h of t is some value. Okay, so it means it's bounded, or it's integrable, it's not infinity, so it means the system will be stable. So if we want to verify, we can verify by BIBO stability. Again, we have defined some input which is from which is 1 from minus 10 to 10. It means it is bounded input, and what we do is we convolve this input with the same h, and what we do, we see the results, and here are the results. तो ये देखें कि इस केस में जो सिस्टम रिस्पांस है ये इनपुट थी, इस इनपुट के का रिस्पांस वो क्या है, this is a bounded input. Output of the system is also bounded. It means the system is stable. Okay, so दोनों तरीकों से verify हो गया कि this system is stable. You can take any other input as well. As long as the input is bounded, output should be bounded. Output should not be diverging. Okay, now if we mathematically say this input is bounded by the capital M, if you remember the capital M from 0 to, let's suppose, 2. Okay, So we can say कि ये जो output है ये bounded है from 0 to 2, इसके दरमियान है, इससे ज़्यादा नहीं हो रही. Okay, so as long as we bind, so as long as the response is bounded by some numbers, we can say this system is stable. Okay, so I think that's it for today.